So, hi, my name is Danny Lee, and today I'm going to present Physics Lab 1. The objectives of the experiment was to first examine motion of the object moving at constant velocity, and second, to analyze video of object in motion via tracker, and lastly, to create a computational model with the use of Python. So, regarding Newton's second law, which is F equals mass times acceleration, when F net is equal to 0, 0, 0 Newton, acceleration obviously becomes 0, and thus initial velocity is equal to the final velocity. And that was the basis for our experiment. So moving on to the graphs that were created with the data that I got from Python and Tracker, you can actually see that the dotted lines represent the actual experimental data, where it's not that, it's kind of linear, but it's not up to the perfect standard. And these are the codes that were created by Python. As you can see, the various equations were used, especially regarding ball velocity equals ball velocity plus F net divided by ball mass times delta t. So the two questions were asked. First of all, what happens when you flip the axis? Obviously, velocity and magnitude would stay the same, whereas directions change. And are the pushes and pulls going to actually change? What's going to happen? Or can you figure out how many of them were figured out? They are unable to be determined. So it's time to watch the video of my tracker file. The ball rolled on a surface with constant velocity. Obviously, you can see in the graph here that it shows a linear pattern of the constant velocity motion. Thank you for watching my video.